We need to use the law of sines or cosines to solve an oblique triangle. And if we look at this one, it looks like we've got angle, side, side. And let's go ahead and put in the pieces. So alpha is 42, which means A, the side opposite it, is 17. And we've got B, but we don't have beta, so we'll write beta here and we'll put B across from it, 23.5. So then this is gamma and this is C. So we need to find beta, gamma, and side C. So do we have an angle and a side opposite pair to use the law of sines? And the answer is yes, we do. So we're going to use that. And we're going to need to be trying to find an angle, so we're going to put the sine on top. Sine 42 degrees over 17 equals, and we'll go for the side, we'll go for beta because we have the side opposite it. Whoops, got to be sine beta. Okay, over the side opposite, which is 23.5. So now we go ahead and solve for the sine beta, so we multiply the 23.5 over here. And whenever you need to, on law of sines, use the inverse sine, this is the one where it's an ASS, and it means that there could be a second triangle. And so you're going to need to always check to see, could there be a second triangle when I find this, and if so, you need to find both of them. So you know it's going to be that when you use inverse sine, where when we did the last law of sines, we didn't ever need to use the inverse sine key. Okay, so what we have is the sine of beta equals 23.5 sine 42 degrees over 17. So we're going to get the calculator, and I'm going to go ahead and pull one up here. And we always make sure before we punch buttons that we're in the correct mode, and we can see the DEG here, so we're in degrees. So I'm going to hit the second so that I can get the inverse sine, and then I've got 23.5 sine 42, parenthesis to finish the sine, and then divided by 17, parenthesis to finish the inverse sine. Okay, and I'm going to do this to one decimal place, so it looks like beta is approximately, oh, and that went away, let's bring it back, 67.7 degrees. Now, we're going to call this beta 1 because I had to use the inverse sine to get it, so there's a possibility of a second triangle, and I'm going to find that out right now. So I'm going to draw a picture here. 67.7 is somewhere in here, but there is another angle in quadrant 2 that has the same sine value over here. So I need to figure out how to find that one. And if this is 67.6, then this other angle is 180 degrees minus the 67.6. So let's take 180 minus the answer that's in the calculator there, and I get 112.3. So I see that there is another triangle because I could have an obtuse angle here and here, 112.3. The 42 that I have and the 112.3 is not past 180, so I know there is a second triangle. You would know there wasn't one if this angle you got when you added it to the angle in the triangle is more than 180, but it's not. So we can go ahead and find our gamma 2. And that one is going to be 180 minus the 42 minus the 112.3, and it looks like that's going to be 25.7 degrees. Now let's go back over here. Since we know there's another triangle, we found that second gamma, but let's find the first gamma. So I'm going to do 180 minus the 42 that's in there minus the 67.7 that I got, and that would be 70.3 degrees. So I do have two triangles, and now I have all of the angles in both triangles, but I need to find the sides. So let's go ahead and find C1, which is opposite gamma. So I would have C1 over sine of 70.3, because that's what we found out was gamma 1, equals, we're going to take our angle side opposite at pair, 17 over sine 42. Now let's solve this for C1. So we'll multiply the sine 70.3 degrees over, and now it's just punch buttons, 17 sine 70.3 divided by sine 42, and it looks like our C1 then is 23.5. Now the last thing we need to find, and we've got both triangles found, is C2. This is the answers for triangle 1. And now to find triangle 2, we need to set up the law of sines, and we're going to have C2 over sine of gamma 2, and that gamma 2 is 25.7, and then we still have our 17 over sine 42. Okay, we can just multiply this sine. I'm going to squish it in, kind of going up the hill here, 25.7. And now it's a matter again of punch buttons. 17 sine 25.7 divided by sine 42, and that is rounds to 11. So this is the two triangle case, and we knew to check for a second triangle because we used inverse sine to find one of the angles.